Go.
Okay, let's look at this problem again. At 0336 while staring at 158 true and at 17.5 north, you observe the following. Cape Columbine light bears 111 true and rock on X on Seal Island is 19.2 nautical miles distance off by radio. At 0500, Cape Columbine light bears 093 true and the South Head light bears 112 true. Find the sets and rates of the current and the cause and the speed made good. Okay, so let's start. At this time you stare this with the speed, you observe the following. So all these observed are observed at this time. You observe Cape Columbine light as 111. So let's get 111 to Cape Columbine light. This is Cape Columbine light. This is our compass rose. So let's just move from compass rose to Cape Columbine light using our parallel ruler. 111 Cape Columbine. 111. Put my pencil in the center. Find 111. This is 110. This is 111. Yes, it is. Move toward Cape Columbine. Just there, Cape Columbine. Then I hold it tight. Cape Columbine is just here, and I'm not going to write from there. I'll just start out there because I don't know where this thing is. Cape Columbine 111. We're good. So the next thing, Cape Columbine 111, recon X on Seal is 19.2 nautical miles. So they just gave us the range of sail, Racon X on Sail Island. So we need to find Racon X. This is Racon X. So what they're saying that Racon X, this Racon X is what is 19.2 nautical miles by distance to our point along this bearing of Cape Columbine. So we're just going to use our divider. Our divider to measure that distance of 19.2. So we just come here, we measure 19.2. So this is my 5, 10, 15, 5, 10, 15. 19 is something about there. 0.2. Here it's 2. Exactly here it's 2. Here 2. So then my divider is just pointed just there. So this is 19.2. 19.2 is measured of what? From the Seal Island, then by a radius. So where is that Racon X? Just here. And then from that Racon X to this thing, or should I say to the previous bearing, to where range met the bearing. So there's something about here. So when these things meet, this is how you will present them. Okay, Cape Columbine bears 111. This is 111, and Racon X is 19 nautical miles off the land. This is it. This is recorded to be at what? At 0336. So time for this is 0336. Okay, we're good. So the next thing, we just did everything that is recorded at this time. Yes, we did everything. Then at another time 0500, Cape Columbine light bears now bears 09 true. Okay, Cape Columbine, where are you, Cape Columbine? This is you. Cape Columbine light bears 039. So from our campus rows, we take that 039 to here using our parallel rule. So 039 039 039 is something about there. It's supposed to go to Cape Columbine. 03039. This is 039, is it? 039. This is it. Supposed to go to Cape Columbine. That is Cape Columbine. Cape Columbine. Okay. Base 039. And yes, we grow that about here. We don't know where about it really is. We draw it. Okay. Oh, from here I didn't say that we were given that we stir this. We stir this one from the position that was recorded or observed at 0339. We stir 158. Let me just put that course. Okay, 158 from our compass rose to that initial point, or maybe should I say point at 0336. We stir what? 158. Where is 158? 158 is here. This is 9858. From our position at 3. Okay, we're good. So we just did that, and we also have what? We also have speed that we're going to run with just here. Speed that is going to use to run just here. Okay, we have a speed. We do have what? We do have times. We do have time from time of departure and time of arrival. Okay, so we can use this thing to find time different. So how do we get our time different? We're just going to do what? You can do this on a casual calculator. It's just a software version of it. 03 degrees 36, or let me start with the arrival time. 05 degrees 00 minutes. We subtract time of departure, of which is 03 degrees, should I say hours, 36 minutes. Then this thing took about what? Took 1 hour and 24. 1 hour and 24. It took us 1 hour and 24. Okay, so we're just going to convert it to only hours as our units. Okay, so we have that 24 divided by 60 for an hour. Then we're going to have 0.4, and we already have an hour 1, so it's going to be 1.4 hours. So this thing took about, it took 1 hour and 1.4 hours. Okay, so we're just going to use that time and speed to get what? Distance. Remember our triangle DST. We want distance. We have speed and time. Distance is equal to speed times time. Okay, what is our speed? Given here to be 17. Our speed is given to be 17.5 knots, right? Times what? Times time. The time, or should I say the duration? Okay, that is going to be 1.4 hours. Then we get what? The distance of what? Distance of 24.5. 24.5. Okay, 24.5 is our distance. So we're just going to measure distance of 24.5 from here and plot it just here. So 24,5. Okay, we got 5, 10, 15, 20. 24 is something about there, and then 24 comma 24,5. Let me just make again 5, 10, 15, 20. 24,5. Middle of that one is 5. This is 24,5. If I was accurate, measure it from the point of departure, and then we get something like, okay, this is our DR position. It simply means that if we could run at a speed of 17,5 knots for 1 hour and 1 hour and 24 minutes, we'll just arrive to that point if there was no effective current or wind or anything. Okay, but then something happened. We then recorded other things, observed other things at 05, at 5 o'clock. We observed Cape Columbian to be 39, of which this is line that I just plotted for Cape Columbian, and then we observed something else. We also observed at 5, observed Racon X Supi at 5. Oh, we also observe a north headlight to be 112. Where is our north headlight? Oh, it's south headlight. South headlight. This is south headlight. So observe this thing to be what? To be 1, 1, 2, true. So you're just going to take 1, 1, 2 from our compass rose and take it to this thing. Okay, so using our parallel ruler, 1, 1, 2. So 1, 1, 2. So it's exactly, this is 1, 1, 11, 1, 1, 2. 1, 1, 2 here. This is 1, 1, 10, 1, 1, 11, 1, 1, 2 is just there. Of what? South headlight. Just take this to south head. South head. We just took it to south head. And this intersects just here with the other bearing. So this is where these bearings intersect. So exactly this is where we are, because this is an observed position. This is where we are at 5, or should I say at 0500. This is where we are. Okay, so we are here, or we observe, or after our observation we discover that we are here at 5, but according to our calculation prior, we were supposed to be at our DR position. So what took us from our DR to where we are? Surely nothing other than what? Current. So we join these points, we join these points, and because what took us from here to here, it is obviously current. It's represented by 2 arrows pointing at the direction of that current. So the direction of current is known as the set, so we can get sets from this line. If I could just take this and straight to the rows, I'm just going to write what? The set. Which is, I read the set of, according to the answer here. Set is what? 003, and I read what? 006, still on a range. Okay, I read 006 for my set. Then we got, maybe I have some accuracy errors, but then we're still in the range of 0.3 to be correct. Okay, the next thing is what took us from here to here? We said it was current, and then from current we can get something else. The distance that current drifts us is called drift, or should I say the effect of current is called drift. So if we could just measure this distance, we're just going to get our drift. This distance we're going to measure, we're going to get our drift. From this line marked 3, we get set, we get drift. From this line we get set and drift. These are terms associated with what? Current. Set is the direction of a current, and drift is the distance or covered by current. And the other thing is rate. Rate is what? Is the speed by current. Oh, yes. Then we use this distance, which we call drift. Then I'm going to read it just here, and I just read something like 4 nautical miles. 4 nautical miles. Okay, I just read the drift of what? Drift of 4 nautical miles. Okay, 4 nautical miles. Okay, with that drift distance, I do have time. I still use that time that I got earlier, a time of 0.124. Okay, so if you have, remember on our triangle, this is our triangle, we do have distance, we do have time, we can get speed. The speed that we get is to be speed by the current. That speed is known as what? Rate. Okay, good. So we're going to use our calculator. We do have drift, the distance, and we do have time, the time that we've just been using, 1,8. Okay, so it's just going to, for speed, distance over time. Okay, so for speed, distance over time, our distance is 4. 4 divided by what? Time. What is our time? 1,4. 1,4. Then we get 2.8. Speed of current, aka rate, is going to equal to 2.85 nautical knots. I mean knots. No, knots. Okay, knots. That is going. This answer is our rate, speed of current. Okay, check here. Are we on a range? I think close enough to it. And for our drift, we got 4. We got 4. Let me check it. We got 4. Did we? Yes, we got 4. I think we read. Yeah, we got 4. Is it 4? No. Is it? Oh, we got 1, 2, 3, 4, 5. Check. Okay, we got 5. Okay, we got 5 for our drift. We got 5 for our drift, and then I should have used 5 here. And then we get a rate of 3.5. Yes, good. Now we get a speed of 3.57. From our answer, we are now in the range. Then we're correct. Okay, remember, from this line that is denoted with 3 lines, we get what? We get set, we get drift, we get rate. Set as direction, drift as distance, rate as speed. So this is where we're from. This is where we ended at 5. So this exactly this is where we're going to get our speed made good, cost made good. Okay, so I'm just going to join these points again, this and that, join them, and they should read as my cost made good. If I transfer them to my campus rows, I think they're good, and I read here, I read 18, I read 332 as my cost made good, 332 as my cost made good. Oh, I made a mistake here. If you read this way because we're moving this way, right? So on your campus rules, you read here, you don't read here as much, as I just made that mistake. So I'm still parallel. I am parallel. Then I'm going to read the other way. Okay, from here I'm going to read the other way, of which I'm reading what? I read from here. I think I'm going to read 151. Okay, yeah. Oh, I read 152 here. I read here, I read 152 as what? As my cost made good. This way, remember, cost made good is denoted with 2 arrows pointing at the direction. Okay, this direction, because we're from here, so we're moving this way. Even on the campus roads, we read this way. Okay, so I just recorded 151 as what as my course made good, of which is still on the range of 153, difference of 0, this distance of 3, which is still on the good range. The next thing that we're going to get is the distance that we covered after the current drift starts. It's still on this line. Okay, this is the actual distance that we covered. We should have covered this distance, but then current pushed us, should I say, current drift us to this one. Okay, and then we're just going to use our divider to measure the distance. This is going to be our distance that we covered. If I was accurate enough, the most important thing is the process. The accuracy is just from practice. Okay, so we're here. What do I rate? 5, 10, 15, 20, 2. 20, let me go back again. Oh, okay, yeah, that is good. Yes, I read 22 here. I read 22. 5, 10, 15, 20, and 2. I read 22 nautical miles, and here they have what? 20.5, still in a good. Yes, still in a good range. Okay, we do have our distance. The only thing that we need to do now, I'm on what? 20.2. Sorry, I said 22. 20.2. Okay, I read 20.2 for my distance, 20.2 for my distance, nautical miles. So now I want what? I want my speed made good. Remember, I still use the time. I do have speed, I do have distance. To get speed, I can use time. Okay, DST, right? We have still have that triangle. I do have distance, I do have time. I can get my speed made good because this is my made good. My made good what? My made good distance, if I would say. So this is my distance divided by time of 1.4 that we've been using. Take my calculator and it's helped me out. 20.2. Sorry, 20.2 divided by what? Divided by 1.4, my time. Then I get a speed made good of what? Of 14.42. Okay, 14.4. Then my speed made good 14.6. Then I'm still on the right track. Okay, I think I'm good.